You see it? For big X values, this is what's called a model, or an end behavior model. That the highest powers will always take over. So you know where this function's going. Again, I don't know exactly what it looks like, but I know it's going to do this. Because this is what x squared does as you go left and right. So this is what this function is going to do as you go left and right. Okay, does that make sense? Okay? So that's if the highest power is in the numerator. If the powers are the same, and I want to know, and this is only for end behavior, guys, for values when x gets really big in the positive or negative direction. If they're the same, if this was like 4x squared plus x minus 5 over 2x squared, we're going to play the same game. Highest powers take over. So what's the numerator going to be and what's the denominator going to be, Michelle?
4x squared over 2x squared.
Yeah, this is going to take over in the numerator, and this is going to take over in the denominator, or it's just going to leave you with what, Magali? When you cancel this stuff out? 2. Graph it. What does that mean? What does it mean that you get 2? What does that tell you about the end behavior of the function? What's that, Marco?
It's just going to be like a straight line.
You know, wiggle, wiggle, wiggle in the middle. But what that means is you have a horizontal asymptote as you go to the left and to the right. Meaning all these powers are going to be the same. So whenever these powers are the same in the numerator and the denominator, the exponents are the same, so the highest, the leading term, they're going to cancel out, and the horizontal asymptote is just going to be equal to the ratio of those two values. Okay? So in this case, it's 2. And the third case, this case, the numerator has a bigger power. This case, they're the same power. This case, yeah, the denominator is bigger. So let's start back to this x squared plus x minus 5 over 2x cubed. Let's just change that one and that one back to x squared plus x minus 5. Well, for end behavior, this is going to behave the same as just the lead terms in the numerator and denominator. Which when you cancel out, what are you going to get here, Roxana? What's going to happen in this case? X squared over 2x cubed if you do some canceling.
2x?
Where is the x at? And where's the 2 at? In the numerator or denominator? See, it's like, it is 2x, but it's all down there. You know what I'm saying when you cancel out?
Oh, yeah, 1.
Yeah, so what does that mean when x gets really, really big? Where's this function going to go?
Say positive.
1 over 2, yeah, this is a good model for the function. And what y value is it going to approach when x gets really big? 0. Does that make sense? Just like the 1 over x or 1 over 2x, this would be like a model function. But when x gets really big, this thing's going to tend towards 0. And so is it in every case when you have a higher power in the denominator. You're going to have a horizontal asymptote at 0. Okay, and is that what you're seeing on your graphs? Okay, so those are the 3 separate cases. Those are 4 horizontal asymptotes. Horizontal asymptotes have nothing to do with anything bad. It just tells you where the function is going as you get outside your screen. So you can have that value. Well, in this case you don't, but in other cases, like we saw earlier, you do, like the sine x over x. Okay? Horizontal asymptotes. Any questions on that? Yes?
Okay, so for the third case,
Yeah.
the exponent of the denominator is greater than the numerator.
Yes.
It's greater than 0.
Always.
And then for the second one, it's the ratio of coefficients.
Yes. Yeah, if they're the same. So if the exponents are the same, the highest power are the same, then it's just the ratio. Yeah, this is like going to be, because they're always going to cancel out, and then it's just going to be 4 over 2, or whatever those two values are.
And then is that, what's the case for the first one?
So the first case is if you have a higher power in the numerator, you're still going to cancel everything out. So every time you just take your highest powers, only what happens here is when these cancel out, you're going to be left kind of with a function still, or with something like x squared. And the end behavior of this is x squared, it looks like that. So what does that mean? That means this is also going to do this. It's going to go up to the left and up to the right. Okay? Those are really the only three things that can happen. Okay, for rational functions. Okay, so this is, again, horizontal asymptotes. Then we get to our buddy, vertical asymptotes. Now, what is a vertical asymptote? When do we see them? What happens with them?